Now we go to the topic of the intensity of sound wave and the decibel scale. So we'll introduce you to what intensity means, and then we'll introduce how the decibel scale works, and then we'll give the theory behind that. And then after that, we can apply that to several different kinds of problems, okay? So the intensity of the sound wave is defined as the power of the original sound source, power of the source, divided by 4 pi r squared. Right? So we're assuming that, of course, the sound wave is traveling in 3 dimensions, right? So that there could be a speaker here or something producing a certain sound wave, and then the power of the sound wave is traveling in a 3-dimensional fashion. So if I want to know what the intensity is at a certain point, like here, so what I do is I take the original power of the source, but the power is being distributed in a 3-dimensional fashion, right, in a spherical shell like this. So what's the intensity of the sound source by the time you reach here, by the time you reach a distance of r? So the intensity is defined as the power of the source divided by 4 pi r squared. Why? Because 4 pi r squared is the surface area of a sphere, right? So this is a 3-dimensional sphere, like this. So this is the surface area of the sphere. So you can say the definition of intensity is equal to power divided by area, but because the sound wave is traveling in 3 dimensions, then the area will be 4 pi r squared. So now let's talk about the units of intensity. The units of intensity are going to be watts per meter squared. And let's also talk about the decibel scale. The decibel scale is a way of converting the intensity of the sound wave to a logarithmic scale, much like the Richter scale. So the decibel scale is going to be 10 log of I, the intensity of any sound source, divided by I0, right? So I0 is some reference intensity, and we call that the threshold of hearing. I0, threshold of hearing, and it's 1 times 10 to the minus 12 watts per meter squared. So that means this is the lowest intensity sound wave that you could hear. This is a very general number because it depends on your age and many other factors what the lowest intensity that you can hear. And the frequency of the sound source also changes the lowest intensity of that sound source that you can hear. Right? Depending on what the frequency of the sound source is, the sound source might have to have a higher intensity for you to be able to hear it. Right? How does this work? If the intensity of another sound source is 10 times greater than that, which would mean 1 times 10 to the minus 11, right? So this sound source is 10 times more intense than this sound source. Why? Because it's only 10 to the minus 11, right? Instead of 10 to the minus 12. What would that be on the decibel scale? Well, let's actually first start. We can say, what if the intensity of some sound source was actually equal to the threshold intensity, right? Let's start with that. What would that be on the decibel scale? And then we can see decibel scale will be 10 log of I0 over I0. So that one is the base decibel scale, right? Well, I0 over I0 is just 1 log of 1 is 0, so that would be 0 decibels. So what would it be if this one was 1 times 10 to the minus 10? So 1 times 10 to the minus 11 over 1 times 10 to the minus 12, right? So then what does that mean? Well, 10 to the minus 12 goes to the top and makes this 10 to the, just makes it 10, right? So it has 10 log of 10. Why? Because this was 10 times more intense than that, right? Then if you take log of 10, what does that become? Well, log of 10 to the base 10 means 10 to the what power gives you 10? So that's just 1, right? So this is 1, and then 1 times 10 is 10. So that means 10 decibels is 10 times more intense than 0 decibels, right? And then we can continue from there. What if the intensity of some sound source was 10 to the minus 10th? Right? 10 to the minus 10th. That means that's 100 times more intense, right? So then you're going to have 10 log of 10 to the minus 12 goes to the top, makes this 10 to the second. So 10 to the second is 100, right? 10 to the second is going to give you what? The 2 is going to come down, so it's going to make this 20 log of 10, and then log of 10 is 1, so this is going to give you 20, right? So this is going to be 20. So 20 is 10 times more intense than 10, but 20 is 100 times more intense than 0, right? Compared to the threshold of hearing, right? So this one, the intensity of this one was 1 times 10 to the minus 12, 1 times 10 to the minus 11, 1 times 10 to the minus 10. We'll do one more, 1 times 10 to the minus 9, and then we have 10 log of, and then 1 times 10 to the minus 9 over 1 times 10 to the minus 12. So we're going to have 10 log of 10 to the third. One is going to be 10 to the third, which is 1,000. Then the 3 is going to come down, make this a 30. Log of 10 is 1, so you're just going to get 30, right? Well, this is very similar to the Richter scale. The Richter is 0, 1, 2, 3, 4, 5, 6, 7, 8. Same way, except it doesn't have, it's not 10, 20, 30, 40, 50, right? Basically, every 1 is 10 times more intense, right? 2 is 10 times more intense than 1, 3 is 10 times more intense than 2, 4 is 10 times more intense, but every 2 is 100, right? So this one is 10, 10, 10, 10, 10, 10, 10. Then you have 100, 100, 100, and then so on. So this compare every 3, right? Every 3 should be 1,000 times more intense, right? So this one should be 1,000 times more intense. 1 and 4 should be 1,000. 4 and 7 should be 1,000. 7 and a 10 should be 1,000. So every 3 is 1,000. So actually we can do the same arguments. 80 is 1,000 times stronger than a 50. 80 is 100 times stronger than a 60. 80 is 10 times stronger than a 70, right? Eventually we're going to get to a decibel scale, which is called the threshold of pain. That one is 120 decibels. Of course, that also depends on the person, well, their age, their tolerance for loud music. So it's all going to depend. So what would be the intensity of a sound source whose the decibel scale is 120? We can now work backwards. We can say 120 is equal to 10 log of I over I0. So I want to solve for I now, right? So then I can say divide both sides by 10. So you have 12 is equal to log of I over, and then I0 is equal to 1 times 10 to the minus 12, right? How do I get rid of log? I can raise both sides to the power of 12, right? 10 to the power log of this over this, and 10 to the power 12, right? 10 to the power 12 is just going to be 10 to the 12. 10 to the log is they're going to cancel each other, 10 and log. Then you're just going to end up with I over 1 times 10 to the minus 12. Then I can cross multiply this. 10 to the 12 times 10 to the minus 12, well, they cancel each other. So that means I is equal to just 1 watt per meter squared. So actually 1 watt per meter squared of intensity is enough to cause maybe damage or real pain to your ears, right? That's going to be roughly the threshold of pain. 40 decibels is usually considered the sound intensity for background noise. So you can kind of get an idea from there. So if you're at a restaurant, you're talking with your friend, and then there's some background noise, in the background, people talking, chatter, and stuff like that. So that would be 40 decibels. If you're talking louder to your friend and you're like next to each other, you'll probably be at 50 decibels, maybe 60 decibels. Actually, these apps you can download to your phone called the Decibel Scale, and you turn it on, and while people are talking, you can actually measure the decibel that they are recording, what the sound intensity is recording, and you can actually talk into it, yell into it, and you can kind of see what the meter is showing. So you can have some fun with that. Okay, thank you very much.